Question 15 asks, a mutation in signal recognition particle that eliminates its GTPase activity would be predicted to have what effect on the secretory pathway? Well, if we look at the secretory pathway, so signal recognition particle, it's a GTPase protein. And as I said, when GTP is bound, the function of a GTPase is turned on. That's the way to think about it. All right, so in the case of signal recognition particle, all right, what is its function? Well, its function, it has two functions, or actually three, I guess I'd say. So one of the functions is bind to the signal sequence of the new protein coming off the ribosome, so it binds to that sequence. The second function, it turns off the ribosome, preventing the ribosome from making any more protein. And then thirdly, it will go and bind to its receptor molecule on the endoplasmic reticulum. So those are the three functions of signal recognition particle. Now, if the GTPase activity was eliminated, signal recognition particle will be able to bind to GTP but not cleave it. So as a result, those functions basically remain permanently turned on. So the ribosome would be turned off for this particular peptide. And that peptide, SRP protein, would remain bound to the signal peptide, the newly synthesized peptide, and it would also remain bound to its receptor at the endoplasmic reticulum. So what would happen is basically the secretory pathway would shut down because the signal recognition particle would keep the ribosomes inactivated. It's sitting there bound to the signal sequence, not allowing it to thread through the endoplasmic reticulum membrane. And so basically all these membrane proteins or proteins marked for export out of the cell, their production would be halted by this mutation. It would probably be a very bad mutation, probably lethal for the organism if it entirely shut down its activity as well. And that's it for this question.